Hello, good morning, good afternoon and good evening, and welcome to another episode of What's New in SimCenter Star System Plus 2306. Together with me in the London Hammersmith studios today, to navigate us, to drive us through all the new features of SimCenter Star System Plus 2306 is Daniele Obiso from the product management team. Hello Daniele, welcome to the London Hammersmith studios.
Hello Rodolfo, thanks for the invitation. I'm very excited to be here today.
All right, excellent. Yes, I think everyone is excited about the release of SimCenter Star System Plus 2306 here. And a question that I always ask, how many new features more or less do we have in SimCenter Star System Plus 2306?
Yeah, for our release we will have roughly 120 new features.
Okay, so that's an impressive number. We are not talking about 120 new features today. We don't want to keep all our audience in front of the screen for all day and all night, but we are going to talk about the main new features.
Yes, that's correct. So we will have an overview on, let's say, some highlights on the most important ones.
And which one do you want to start with?
Yeah, sure. So I would like to start with a great feature which is called gradient-based adjoint optimization.
All right.
I'm very close to this feature since this is coming out of a collaboration between two different teams, the adjoint team with which I'm working closely and the design manager team. And it is a great feature in my opinion. So it belongs effectively to the design manager workflow, and it is an alternative optimization workflow to the classical Sherpa optimization. And this new workflow can provide you a faster way to reach a local optimum. So the way it works is that it leverages the sensitivities and therefore gradients basically from the adjoint solver to speed up, to drive the optimizer towards the local optimum, and therefore can significantly speed up the optimization study. It is applied to CAD design studies, so these are optimization studies of CAD parameters. And therefore, as we understand, the benefit of this new feature increases with the number of parameters that are used in the study.
Right. So basically it is more competitive than Sherpa when we have a high number of design parameters that we want to optimize.
That's correct, right. Because in this case, at each optimization iteration, the optimizer already knows in which direction all parameters have to be moved.
Right. I think all the people watching from home and the office may have a question. Does it mean that you have to create your geometry in the 3D CAD, in the SimCenter Star System Plus 3D CAD?
That's of course one option, but we also support CAD clients, so you can also have your native geometry parameterized in a CAD client, and this is also supported by this feature.
Okay, right.
We can have a look at this example, which is shown here in the slide. This is an optimization of a U-bend geometry where we use 18 CAD parameters. And in this case, comparing the classical Sherpa optimization to the new gradient-based optimization, we can go down from 247 design studies to 22. And of course, this has also a consequence on the computing time, which is reduced from 42 hours to 4 hours, so it's quite impressive.
Right, and I believe that all the audience watching us has another question, which is from a licensing point of view, how does it work? My understanding is that this is including in the SimCenter Star System Plus Intelligent Design Exploration add-on. Is it right?
That is correct. As I said before, this feature belongs to the Design Manager workflow, so yeah, that's correct.
Okay, that's an excellent first new feature for this SimCenter Star System Plus 2306 episode. And to present other two great features today, not Daniele this time, but we are connecting remotely with our colleague Mahmoud, and I think that Mahmoud is ready to join us. Hello Mahmoud, how are you today?
Hi, Rodolfo. Hi, Daniele. Happy to be here. I'm doing very well. I'm excited to be here to talk to you about a few features that I have in the Geometry Handling 3D CAD module and Star CCM Plus in 2306.
All right, that sounds terrific. Please go ahead, tell us more about that.
Okay, so for the first feature I'll talk about is the 3D CAD in parallel simulations. And currently, the complexity of real-world geometries are increasing and will continue to increase over time. And as those geometries continue to grow in complexity, and so does the memory footprint that comes along with them. On the same note, the use of parallel simulation is following the same trajectory, and this presents us with a challenge to keep up with the geometries of today and the future as well. In turn, we improved the way we handle 3D CAD geometry in SimCenter Star CCM Plus 2306, where the overall memory consumption during these parallel simulations is significantly reduced, as the 3D CAD geometry is now only instantiated on a single node, and the remaining nodes will reference the geometry that is present on the single node.
So how does the memory consumption change in 2306 compared to the previous versions like 2302?
Well, to answer that, we can look at a plot of one of the example models that we tested in the development process. We're comparing the previous releases to 2306. We can clearly see that there's almost no increase in the total memory consumption across the nodes in comparison to the previous versions, where with each node used, the memory consumption would linearly increase. And that makes sense, right? Where in the previous version, every single node you use and a single processor that you use extra, the geometry will be copied and live on that node as well. Where now it's only going to be referenced on those nodes and instantiated on the main node.
That's very good. Then I have a further question. So this is the new default. So users are not expected to change any settings in their setup, right?
Yes, you're absolutely right, Rodolfo. It's the default. It will always be on. The users do not have to change anything to activate this. It will always work. Once you have your parallel simulation, this will automatically happen in the background.
Okay, that's very good. You mentioned that you have another feature you want to present, right?
Yes, Rodolfo. So the second feature that we're excited about in the 2306 release is the Mesh to CAD feature. And this feature enables the conversion of tessellated-based geometries to CAD-based bodies.
And sounds very interesting, but what is exactly the benefit of having a CAD body rather than a tessellated body?
Well, there are many benefits to this conversion to CAD bodies. I'll try and give a few examples here. In the first instance, let's say the CFD analyst might not have access to the CAD geometry and is only supplied with a tessellated mesh as a starting point. This is actually quite common for some in-cylinder simulations and the workflows that they use in this vertical. In some cases, that's acceptable. However, the geometry might possess certain elements that are not necessary for the CFD analysis. And relying on the tessellated geometry, the analysis is not able to perform the necessary defeaturing and removal of those elements in the geometry. This is where converting to a CAD body, the user is able to defeature the geometry of those elements for the analysis, and also to extend that, have the ability to parameterize the geometry for design studies and do more exploration of the design space that way. Another example that I can give as well is the evaluation of differences that occur between the geometry used in the CFD simulation and the actual geometry manufactured. As you know, Rodolfo, the manufacturing process typically introduces some defects, and in certain instances, those defects can have an adverse effect on the performance of the part. And utilizing the new Mesh to CAD feature, the user is able to scan the manufactured part independently and then use that scanned data to create a CAD representation, which can be further analyzed to ensure that the performance is what is expected of it.
Thanks, Mahmoud. Then regarding specifically this second feature, is there any limitation that you want to mention or highlight?
Well, there is some kind of limitation here, and we are continually improving the algorithm. So this is our first step at creating this feature and the algorithm to convert these tessellated geometries to CAD-based geometries. And the limitation that we have for this first release is the feature is not meant and will not be able and capable to generate a complex assembly from a huge tessellated grid, right? These are things that we're working on to overcome these limitations and hopefully be able to provide them in subsequent releases where you can have these large assemblies that are coming in these tessellated formats and convert them to CAD-based bodies. At the moment, it is able to do them in chunks, but not as one huge complex assembly.
Well, you present really two terrific features. So anything else you want to add?
No, nothing else from me. Thank you for having me here, Rodolfo. Thank you, Daniela, as well, for being here. Hopefully, in the future, I can come on and explain more features that we bring in from the geometry side. And I'm hoping for positive feedback on those two features from our user base as well.
Yeah, and I really hope one day to have you here in London rather than remotely. And
yes, hopefully.
All right, so great. Thanks, Mahmoud. Thank you very much for joining Daniele and myself in this What's New in SimCenter StarSCM Plus, and have a great rest of the day. Daniele, back to you. Great features from Mahmoud, right?
Yes, very nice features indeed.
Okay, so back to you. What are you going to talk about now?
Yeah, I would like to spend a few minutes on GPU-related topics because the release of SimCenter StarCCM Plus 2306 is very much GPU-focused. So I wanted to show some highlights on the features and capabilities released there.
Right. Please go ahead.
Yeah. So let me start from the first one, which is the release of a GPU-native coupled flow and energy solver, which allows our users to run much faster simulations such as external aerodynamics for aerospace or automotive industries, and to some extent some turbomachinery as well. So it is an important feature that is going to have a big impact in our user workflows. And in the slide that you see here, we can have a look at an example. This is an example of aerospace aerodynamics, and it is focusing on a very well-known case, I would say, in the aerospace community, which is the high-lift CRM model. And so it is a case of roughly 110 million cells and can be run in 40 minutes on GPU.
Wow.
So this is using 24 NVIDIA A100 card. And if we compare this to a CPU solution, which for this case here was using roughly around 600 CPU cores on, let's say, state-of-the-art CPU hardware, we have a reduction of computing time of around 84%.
That's impressive, yes. One thing that we should probably mention, so you said that it is a native couple solver on GPU. It is true that it is native, but probably we want to reassure our users that the physics of the couple solver, whether it is on GPU or CPU, and actually this is true for all the other solvers that we implemented on GPU, the physics is exactly the same. So this guarantees a complete compatibility between the two versions and a complete consistency of the results. And so basically when we port a model on CPU, we want to offer our users the most seamless experience in transitioning between one hardware and the other.
Yes, that is correct. This is a very key aspect for us. And we can also appreciate this from the picture shown here, where we are looking at a comparison of skin friction distributions between a CPU and a GPU solution. And as you can see, we really can get to CPU equivalent solutions when using GPU hardware. And as I said, this is a very key point for us, and we ensure this by basically maintaining the same unified code base. So we don't have a siloed product to be run on GPU.
So our physics developers are almost unaware, actually, where the code they write will be ported to, right?
Yeah, that's not entirely correct. They're still involved, but yeah, we can reward it like that.
Yeah, almost unaware.
Almost, yeah. Another important information that I want to share here is also about cost. So it is great that running on GPU we can save computing time, but at the same time you can also save cost. So the estimation which is shown in this slide, is comparing a CPU and a GPU run on, let's say, a popular cloud vendor. And as we see, there is a significant reduction in costs as well.
Yeah, and do something good for the environment as well, which is something we all care about.
Exactly.
Saving electricity and carbon dioxide emissions.
Exactly. So I go on with a second GPU related feature, which is a GPU native flamelet modeling. So in SimCenter StarCCM Plus 2036 will be possible to run combustion on GPU. And this comes along also with the LES turbulence model, which is already available since the release 2210, and with the piezo transient scheme, which is also introduced in the June release. So it will be possible to run transient combustion simulation leveraging LES and piezo. And in this slide, we can see an example on how we can leverage all these models for a thermoacoustic simulation for an industrial pressurized burner. And as we can see on the left side, we have very good predictivity of the thermoacoustic modes. And as also observed previously for the couple flow solver, here comparing again a CPU solution running on more than 600 CPU cores and a GPU solution using 8 NVIDIA A100 cards. Again, we have significant reductions in terms of computing time, costs, and energy consumption. So to continue on these GPU improvements, so we have seen now new models added to our portfolio, but we are also constantly working on improving our performances on GPU. If we compare, for example, the performances both in terms of computing time, but also memory usage from our first release, which was out last year, 2022, with our latest release, SimCenter StarCCM Plus 2036, we can here appreciate a constant reduction of these two aspects.
So I think this is a very, very important point. We started our travel in the GPU world about 16 months ago, 18 months ago, I think. And when we implement a new model, a new solver on GPU, we don't consider that a problem solved, but for us this is a continuous journey where basically we improve both implementing new models, importing new models on GPU, but also improving whatever has been done, as you were saying, either reducing memory consumption or improving speed and so forth.
That is correct, and we are still doing that, so more improvements are to come.
All right, Daniele, anything else you want to say about the GPU?
No, I think this is all for today.
Absolutely. So you are not leaving, we will be back to you later.
Yes.
But now we have other 3 exciting new features, and to talk to us about that, we have Jan connected remotely with us. Hello Jan, how are you today?
Hey Rodolfo, hey Daniele, how are you doing? Greetings from Germany.
We are very well, thanks. And I heard you will present 3 exciting features today. Which one do you want to start with?
I would like to start with a feature called Create Point Probes from a File Table.
Okay, that sounds very exciting, and it seems I can finally throw away my macro, right?
Yes, that was the intention of the feature. So let's see how that works. In StarCCM Plus, if you import a file table, you are now able to directly derive from that file table, based on the locations, hundreds or thousands of points. So if you imagine an array of acoustic microphones, for example, you can use those locations in XYZ and directly create point probes from those locations. These newly created point probes are grouped together, and we added a small feature there in which you can highlight actually this group, which was not possible before, so you can easily see where the points are located. And furthermore, which is another nice troubleshooting feature, we also now added an option to also highlight points that are not existing in the meshed areas. So maybe if you made a mistake during your importing, you do not really know where your cloud of points is located, you will be able to just highlight these points as well and therefore get an understanding of where your cloud point is actually located. So we find that it's a very helpful feature for troubleshooting these kind of imports.
You mentioned acoustics. What else can I use this feature for?
So besides acoustics, one could mention complex piping systems, and we really put point probes in individual pipes to investigate, let's say, the flow velocity or any other application where you basically are in need of dozens of derived part point probes in order to understand better your system.
Thanks, Jan. And you have a second feature to present today, which is still about data analysis, right?
Yes, and I'm actually quite excited about this one. It's called the multi-valued monitor, and it will make workflows involving plotting on hundreds or thousands of parts much easier. So let's imagine you have created 100 points and you want to plot a value on each of these points. In the past, you would have to build an individual monitor for every single point. Therefore, your simulation tree would get quite convoluted, and also to manage such an amount of monitors is also a little bit challenging. So in order to fix this or make this better, we created the multi-valued monitor. This allows to input, as the name says, multiple inputs into one singular monitor, and therefore makes these workflows much easier. So how would that look? Again, you would have these 100 points, but you would only have one individual monitor and one plot in which this monitor is being shown. So it makes everything considerably easier and much easier also to automate. So we're quite happy about this one.
And what is the last feature you will present us today?
So this feature is for the SimCenter StarCM+ web viewer, and it's called clipping and slicing.
Before going ahead, I think there are a lot of users, a lot of attendees watching us today that may not know exactly what the web viewer, what the SimCenter StarCM+ web viewer is. So before explaining the feature we are adding in SimCenter StarCM+ 2306, why don't you spend a few words about the SimCenter StarCM+ web viewer?
Sure. So we added the SimCenter StarCM+ web viewer a couple of releases ago, and it is a browser-based viewing application in which you can use a StarCM+ scene file and visualize it directly in the web. You can take that scene file and send it to your sub-suppliers, send it to your colleagues or to your customers. And it is also possible to not only visualize scenes, so visual representations of your geometry or simulation results, you can also visualize plots there. And as you are familiar with this clipping and slicing functionality from StarCM+ itself, we are adding that functionality now in the web viewer as well. So what does that mean? Basically, based on the scene file, you can use a resampled volume, and you can dynamically slice through this resampled volume to qualitatively investigate your flow field and further underline your simulation results with plots that you added to such scene file. So it is a very powerful and quick way to make a decision based on a very light data file. That is the whole idea of it. And we will further improve or enhance the functionality of the web viewer in order to make that much more performant, because we see that it has quite a bit of potential.
Okay, Jan, thank you very much for presenting 3 really awesome features. I can tell you that I already started using them in SimCenter StarCM+ 2306, and I love them. And I'm sure that a lot of the people watching us from home today will love them as well. So thank you very much and have a great day.
Thank you, Rodolfo. Thank you, Daniele. Very good to hear that you like them. I feel the same, and I wish you a nice day as well. Take care. Bye-bye.
And Daniele, back to you. So, what's going to happen now? A laptop is now on the desk, and those of you who attended the previous episodes already know what is going to happen. As usual, we asked Daniele to present, to demonstrate, and to show as many new features as possible in just 3 minutes.
Well, that's a hard task, Rodolfo.
It is hard. Are you prepared?
Yes, I am.
Okay, I'm prepared as well with my stopwatch. I have an easy roll in this game. And 3, 2, 1, go!
Okay, so I have here an open session, and first of all, we see that we have a revamped user interface, which is a new feature.
Yeah, and
in the meantime,
that was easy.
I create a new mesh operation, so I select polygonal mesher, surface remesher, prism layer mesher, okay. And from the surface remesher, I select the quad dominant meshing method, which is now available with prism layer mesher.
And that's new.
Create new surface control, and here I select my part, wheels, and under control, prism layer, custom, we have several other options available, as we can see here.
It is possible to customize many more settings of the prismatic layer.
So now I assign, I create region boundary for the parts, and go to continue, and we create a new physics continue. So let's start selecting models, 3D, gas, couple flow, constant density, steady,
2 minutes left.
turbulence, oh wow, okay, Epson, adjoint flow, okay, that's all. And so we go to tools, field functions. We see that we have new field functions available related to the prism layer.
Indeed, so the prismatic layer exposes new
create
field functions for analysis
a
and
new
so
filter, boundary, okay.
New filter, right?
We assign it to
I know what you're doing, I think.
Parts. So here we assign the filter that we just created, and now we can see that we can we have dependencies from the filter.
Dependency was available for a lot of other objects, but not for filters. This is a new feature.
New report, maximum absolute pressure, and assign parts here. Then I also create a new group.
1 minute left.
And we can now create new reports directly from the group, which is a new feature.
Yes, improved grouping functionality.
I now create visual annotation from report.
Okay, visual annotation is not visible here because we have no mesh and no solution, but please try it because it is an exciting new feature of 2306.
Exactly. In the meantime, I have created a monitor from the report.
Right.
And we can now select or deselect the parts directly in the monitor without need to go
multi-valued monitors, great. 30 seconds left, actually less.
Okay, so now I go to derive parts and create a line section.
Yes.
Derive parts, which is a new feature.
Yeah, which avoids
I go down
tedious
to
workflow.
So import now a table.
All right.
Rows,
CSV
and
table.
I go back to the derive part section and create points from table, a new feature.
Probes from table, excellent.
And to conclude, I go to adjoint, and we have
Stop.
compute parameter sensitivity.
Okay, right at end. Daniele, I think I counted 11. We had a record of 13, by the way. We haven't mentioned these.
Are you sure? I think it's 12.
12? What was the 12th? I may have miscounted it.
Well, I selected the couple flow solvers, which is now
Yes.
available on GPU, so it's 12.
Okay, that is a bit borderline, but I'll give you this. Yes,
Thank
12
you,
features then. Well,
yeah, nice challenge.
well done. Yes, 12 features in under 3 minutes is not easy. And well, we are at the end of this episode. So Daniele, thank you very much for being here in the London Hammersmith Studios. It was a great pleasure. And we have to thank quite a few people who contributed to this. All the product managers who presented the features in this episode, but let me thank especially all the great SimCenter Star System Plus development team, all the great developers, without whom all these new features certainly wouldn't exist.
For sure.
This is just a very, very small part of the new features implemented in SimCenter Star System Plus 2306. It is always difficult to make a selection when we have to build these episodes, and it is so difficult for us to skip, to leave out so exciting new features. We can mention a great stability improvement for oil area multiphase in 2306, the phase coupled Richow. Still in multi-phase, in VOF, there is an option to reinitialize the volume fraction. Still in VOF, we have the variable compression for the modified HRIG scheme. And what else helped me?
Yeah, I can mention that we have a great improvement in workflow for battery simulation.
Absolutely, yeah.
And also for EMAG simulation, we have added a new model, the lamination layer models, which is a great tool for simulation of e-machines.
Right. And I think including these features that we briefly mentioned at the end, we probably reached 20 new features mentioned today, including these at the end, including the features shown in the challenge, and including all the features presented by the product managers in this episode. So probably less than 20, I didn't count them, out of 120, almost 120 new features implemented in SimCenter Star System Plus 2306. So please download the new version as soon as you can and start using it, and I'm sure you will find it very, very exciting. Daniele, thank you very much once again for being here. I hope to see you soon in the London Hammersmith studios. And last but not least, thank you very much all our attendees from home, from your office or from your home office. And I hope to see you soon at another episode of What's New in SimCenter Star System Plus.
Thank you.
Thank you and bye-bye.